So let's look again then. If we have the dot 0, 1, the dot 2, 5, and the dot 1, 4. And let's say that we have another ordered pair. Let's say that it's 3, 5.5. So that dot would be right about here. And another dot, 0.5, 0.5. And that dot would be here. So if we were to attempt to draw a line of best fit through here, it might look something like this, where we would have some dots above the line and some below, but we would try to balance it out in some way. So let's look at the differences then between the y-coordinates of these ordered pairs and the y-coordinates of the dots on the line. Here we'd have a little distance here that we might call D1, the distance between the actual ordered pair, the y-coordinate of the ordered pair, and the y-coordinate for the same x value, in other words, when x is 0, that appears on the line. And let's do the same thing for this particular x-coordinate, 0.5. So we'd have a distance here that we might call D2. And if we were to take the observed y value and subtract from that the y value or the y-coordinate on the line, this first little distance here would be positive, larger value minus a smaller value, and this little distance here would be negative, smaller value minus a larger value. Here, with the observed value on top again, might call that D3, that'd be a positive value. Here, we'd have a negative value if we call that D4. Now, if we were to add up all of these distances with some of them positive and some of them negative, we could actually come up with a line. We could actually come up with infinitely many lines where that sum of those distances would be 0. So rather than adding up just those distances, what we're going to do is we're going to add up the squares of those distances. And what happens when we square these values is they become positive. So now we're adding a bunch of positive values, and we might call this distance capital D, let's say. Now the line of best fit that models the relationship between x and y would be the line with the smallest value of capital D. This is called the least squares regression line. And that equation that we would come up with when we find that least squares regression line, and there is only one, would be the equation that we would use to predict values of one of the variables given a value of the other variable.